today we have a fun lab, if you were in class for it, called Stoichiometry and Gravimetric analysis. And as you have seen in your, or read about in your pre-lab, we have an unknown solution here that has been made in a larger vat. This is just a sample of it, of a sodium carbonate solution, Na2CO3. And what you notice is that solution, I poured it out into a little beaker here, is a colorless, clear solution. And we're going to be reacting that solution, a known amount of that solution, with a excess amount of a known concentration of strontium chloride solution. And I poured some of that out, and that is also a colorless, clear solution. All right, let's talk about how this technique and how the science behind this works. So what you see here is a model of that sodium carbonate, that unknown concentration of sodium carbonate solution. The AQ that follows the formula means that solid salt has been dissolved in water. So what does that mean? Well, that means that these ions, the two sodium ions of +1 that are bonded to that carbonate, that polyatomic ions -2 charge, is actually ripped apart, what we call dissociated in water. And what they become is free floating ions, always in a mole ratio of 2 sodium ions to every 1 carbonate anion, because that's what the formula is, a 2-to-1 ratio. So depending on how much sodium carbonate has been dissolved, there could be more than this, there could be less of this, and that's what we're trying to figure out, is how much sodium carbonate is dissociated within that solution that was made. And we're going to be reacting that with a very similar, like we saw, an aqueous strontium chloride solution. However, we know the molarity for this. This is 0.3 molarity. And just like before, the AQ means that the water has come in and dissociated these ions into their separate pieces in a mole ratio of 1 strontium ion to 2 chlorine anions. And of course, that would repeat in order to make a 0.3 molar solution. So let's see what's happening when these two are mixed together. These two solutions are mixed together and what we get as products. So chemically reacting these two solutions, we're going to write out a formula equation here. We have the sodium carbonate aqueous reacting with the strontium chloride solution. And back in our last chem class, this follows a double replacement reaction pattern. So that means these two metals that I have drawn in green are going to switch places with the anions. So on the other side, what I'm going to do is just the symbols first. I'm going to bring the sodium symbol, and that will now not be bonded to carbonate. It'll now bond to the chlorine anion. Again, I'm not bringing the two. I'm just going to bring over the symbols. So I've got Na that is now going to be bonded to the Cl. And coming back to this side, the strontium will get rid of its partner chlorine and come and combine with the carbonate polyatomic ion. So it's got a new partnership, Sr, bonded to the CO3. Here I bring the 3 because that's the formula for that 1 polyatomic ion, carbonate. Now to balance this side, I'm going to look at the charges on the periodic table. Sodium is in the +1 family. Chlorine's a halogen with a -1. +1 charge ion, cation, with the -1 anion cancels out. So this is a good formula. Strontium, like we saw in the previous whiteboard, has a +2 charge, and the polyatomic carbonate, if you want to use your formula list for right now, is a -2 charge. So +2 -2, 1-to-1 ratio, that cancels out. That's a good formula. The only thing is, when these combined, we still have a lot of water in there. So whether this be aqueous or what we call a solid form, precipitate or a liquid or whatever. We don't know that yet. Okay. Well, we can use some common sense here. NaCl is sodium chloride, right? We know that sodium chloride, salt, table salt, when we put it in water, actually dissolves. So we can, instead of making it a question mark on what phase it's going to be in or form, we can right away know that the water will dissociate those two ions. They won't be held together in a compound. They'll be separated, much like ions were on this side. Strontium carbonate, though, this has to be, by process of elimination, the solid. This has to be what precipitates out. And when you see us mix this in a little bit, you're going to see this form as a white, kind of cloudy precipitate. And that is what we're going to filter out and purify, dry out, and get the mass of at the end of this lab. That mass will allow us to do stoich to figure out how much of this was in that solution to begin with. Okay? So that's what the symbology looks like. Of course, the last thing I always want to do when I'm writing an equation, hopefully you're yelling it at me, is balance it, right? So you notice I got 2 sodiums on this side. On this side, in this formula, I only have 1. So it would be wise to put a coefficient of 2 in front to balance that. That coefficient of 2 also means I have 2 chlorines. When I come to this side, you'll notice I've got the 2 chlorines, so that helps balance it. The last thing is strontium. I have 1 strontium. If I come to this side, I have 1 strontium and 1 polyatomic ion of carbonate. And if I come to the other side, I have 1 polyatomic ion of carbonate. So this is my balanced chemical equation with the forms of the products, NaCl being an aqueous solution still. All that water in the beaker has ripped apart those 2 ions, but the strontium carbonate, those ions have stuck together, forcing the water away. The water's not strong enough to rip those ions apart, and that's what creates the precipitate. All right, now that all the chemical theory is done, we can get into actually taking some measurements and running the lab. So what I have here, let's just explain this really quick, is the top part of what we call a Buchner funnel. And I've labeled it Heart Chem, so we know that that's our Buchner funnel top. And what this does is it attaches, I'll kind of turn around here, to the bottom part of the Buchner funnel, which is right here. And that is then connected into what we call a vacuum flask. And the vacuum flask, I'm going to be using our vacuum pump for this one. That gets a hose connected into the side, and when the vacuum pump is on, it starts sucking. It really sucks. Sorry. And what it does is it creates the vacuum, that suction downward, so whatever we put up here will actually be pulled through those holes and filtered. And that'll hopefully be the distillate from our reaction. In other words, the distillate is all the aqueous products and leftover reactants that will fall through. And it's going to fall through the filter paper, and hopefully the filter paper captures all that precipitate, all the strontium carbonate. Okay, so the very first thing we're going to do is measure the filter paper. We're doing some pre-thinking here, nice and dry. So I'll let you get that data. And the second thing we're going to collect here is the mass of the nice and dry and clean Buchner funnel top. All right. When we come back, we'll mess with the solutions. All right, I've got the top of the Buchner funnel all set up. I've got the vacuum flask on, that's that noise. And one of the techniques that we want to do is, instead of just leaving that filter paper dry, we should actually squirt it with some distilled water, get it wet, and I'll show you what it's going to do here with that vacuum that's on. It should create a really nice seal. I'm going to push down in a couple places here. There we go. Get the sides all sealed in there so none of the precipitate that we're about to form escapes. That's a good sound, actually. And what it's doing is from the vacuum, you can see on the bottom that the water that I squirted in there is being sucked through. And this, in essence, is what we're going to use. Wow. Oh, it's a really good suction to get our precipitate. So I'm going to shut this off, and we're going to come over to the side. So on the left, I have the unknown concentration of sodium carbonate. And on the right, I have the known 3 molar strontium chloride solution. So here's a close-up of the unknown concentration of sodium carbonate. It says in the directions we should measure out about 15 milliliters. I'm going to let you guys record what the actual volume is that we're reacting today. And I'm going to slide over. There's the beaker we're going to mix in. But here's the strontium chloride, the 3 molar, or 0.3 molar, sorry. That's really strong if it were 3. And it says to mix with about 25 milliliters at first. Now, remember, this is the excess reactant. It doesn't really matter to take an accurate measurement here because we're going to make it excess, okay? We're going to react that excess with all of this volume of sodium carbonate, okay? So what I'm going to do is take this, pour it into our beaker, and get every drop in that I can. There we go. And we're going to take the strontium chloride here, and you will actually see the precipitate form very quickly as it reacts. It's going to be a white, there it is, a white kind of powdery, cloudy precipitate. I'm going to get all of that strontium chloride in. Here I got a glass stir rod that I'm going to use just to mix, get things colliding in there. I'll leave that in there for a second. And to that, I'm going to really make sure all that sodium carbonate has been reacted, and I'm going to add an additional 10 milliliters, or abouts, of extra strontium chloride, really making it the excess reactant. So I'll dump that in. If there was any unreacted sodium carbonate in there, it is reacted now. And I'm going to mix it. So you notice it didn't all just solidify. We have the solid mixed in with a lot of liquid. Well, what's that liquid? Well, that liquid is the product NaCl aqueous solution. It's a lot of the extra water that was already there in the solutions. And because we made that strontium chloride the excess solution, we've got some excess strontium chloride in there. So the NaCl, the strontium chloride, the water, those are all contaminants that I want to get out, and I just want to separate out that strontium chloride precipitate that's there. I'm going to do that by using the Buchner funnel. So I've got the vacuum flask running, the Buchner funnel. I re-wetted the filter paper just to make sure it had good suction. And now we're going to pour in the precipitate into the Buchner funnel. I'm going to kind of go slow here, so that I don't just like dump it in and it's all liquidy. I want to try to make sure that the precipitate gets trapped on that filter paper and it doesn't like leak out around the sides of the filter paper. Hopefully my solution that's getting sucked through to the bottom of this funnel is nice and clear. If it's cloudy, that means I lost some precipitate. Okay, so let's take a look. Oh, nice and clear. Now, the problem here, though, is that I still got precipitate in my beaker. So what I'm going to do is just use some distilled water, and I'm going to wash down the sides of the beaker, and I'm just going to continue to pour that off into the Buchner funnel until I have all the precipitate captured. And I will do that until my beaker's clean. Now that my beaker is pretty much clean, the best I could get it, I'm just going to take some extra distilled water here and I'm going to wash that precipitate. And what the washing does is it's going to get out all of that sodium chloride, that excess reactant strontium chloride, hopefully wash the precipitate so it's just sodium carbonate, and that's all it is. Okay. Do that a couple times, get it really nice to ensure that it's a pure precipitate. right. And now what I'm going to do is let the vacuum kind of suck out some of the liquid out the bottom. And notice my filtrate is pretty darn clear. Not bad. A little bit of tinge of cloudiness, so not a lot of precipitate got through. Not a bad filtration. And I'll turn off the vacuum, and we'll move the top of the Buchner funnel into the oven. So here I have the Buchner funnel. The only thing I have to do now is get out all the water that is in that precipitate. It's still pretty wet. So what I'm gonna do is pop it in the oven here, and we're gonna leave it to dry overnight. It's another class. So when we come back tomorrow, it should be all dry, and we'll be able to measure the mass of just the precipitate. And through the magic of video again, it has been sitting in the oven. Let's open it up and see what we got. Take a look at that precipitate. Solid is kind of cracked up, crystalline structures coming in place. Looks pretty dry. Hopefully it's dry. If not, I'll let you guys think about what it not being dry would do to the results here. And let's measure it. So I am measuring this precipitate with the filter paper and the Buchner funnel lid. And here's our final mass. So the rest of this is for you guys to use the data and calculate out how much sodium carbonate was in that solution to begin with. Let's figure out that unknown molarity. Good luck.